Hello everyone, let's talk about exponential and linear growth. So the first thing we need to decide is this thing growing in a linear fashion with a constant rate of change, or is it growing in an exponential fashion where each successive term is a percentage of growth? So if I look at this first problem, you can see that on the x values I'm adding 1, so -2 plus 1 plus 1, and on the y values I'm adding 3. Okay, so the change in y over the change in x, the change in y is 3 over 1. And since it's always 3 over 1, this is called the slope. This is a constant rate of change. Okay, so in this problem, this is a linear model because it has a constant rate of change. If the slope is always the same, if the change in y over change in x is always the same, then it's a line. So to write the equation of a line, we just say y equals mx plus b, and since we have the y-intercept, -7, and we have the slope, 3, we're just saying 3x minus 7. And you can check that. If you've got your calculator, you can just plug in a couple points, like 3 times x is -2 minus 7. So 3x minus 7, I should get -13, and I did. 3 times -1 minus 7. I should get -10. So I'm plugging in the second one, and I did. Good. Okay. So this is a line, not a big deal. If it's linear, you will see a constant rate of change. You will need to find a slope and a y-intercept. So let's look at this one. Looks like we're adding 1 again for our x's, so plus 1. That's good to know. For the y's, it looks like we're adding 4. 3 plus 4 is 7. Yep, okay. So the change in y over change in x is 4 over 1. That's the slope. The slope is 4. The y-intercept is -9. So y equals 4x minus 9. And just for good measure, let's plug in one of the points. 4 times 4 minus 9 should get 7. Got 7. I know I did it right. Okay. Those are linear models. You guys have done a bunch of linear equations. Let's check this one now. All right, so, okay, now wait a minute. I see 48 to 24, that's 24, and this is minus 48, and that's 96, and that's 192. So those are not the same. These are changing. So this is not a linear model. This is an exponential model. And what we need to do is figure out what's the percentage each time. And what we can do is say, what's 192 divided by 384? It's half. What's 96 divided by 192? It's half. What's 48 divided by 96? It's half. What's 24 divided by 48? It's half. Yeah, see, each successive term is half the next. So what I'm going to do is say my growth factor is 1/2. That's if you think of an exponential model as a times b to the x, we know the growth factor, but what we don't know is where we started, so we need to find f of 0. So to find f of 0, look at your pattern. 5, 4, 3, 2, 1. I want to find f of 0. What would you have to do? We would take 384 and multiply times 2 to get 768. And now my model is 768 times 1/2 to the x. Y equals, the initial value is 768, and each term is half of the next one. So if I try this, 768 times 1/2, oops, come on, to the first, I should get 384. I did. I'll try to the second. I should get 192. I did. I'll do one more just for good measure. The third, if I plug in 3, I should get 96. Okay, so here each successive term is half of the next one, so the ratio is 1/2. Let's try another one. All right, first of all, 144 minus 96 is 48. So this first one went up 48. 216 minus 144, this one went up 72. So it's definitely changing. Let's do one more. 324 minus 216, 108. And then I got it right here, might as well do it. 486 minus 324 is 162. So since it's increasing each time, the amount that it's growing is increasing each time. This is an exponential growth, and what we need to do is figure out how is it growing. So what did you multiply 96 by to get 144? 144 divided by 96 is 1.5. So I can try and just take this pattern. 96 times 1.5 is 144, times 1.5. 216 times 1.5, 324 times 1.5. So each one is 1.5 times as big as the next, so we'll say B is 1.5. Now we need to find the initial point. We've got it right there. So if it's A times B to the x, the initial point is 144, and the growth factor is 1.5 to the x. So y equals 144 times 1.5 to the x. I'm going to actually make a table on my calculator. 144 times 1.5 to the x, and we'll check it this way. Go to table. 0, 144. 1 is at 216. 3 is at 324. I'm sorry, 2 is at 324, and 3 is at 46. So I know I did it right. Okay. So what you need to look for is, are they changing by the same amount, or are they changing by a changing amount? If it's different, then it's an exponential problem. If it's the same, then it's a linear problem. So let's do a couple of these problems, practice problems here real quick. First thing, I'm going to figure out how this is changing. So 256 minus 192, it went down 64. 192 minus 144, it went down 48. So I immediately know this is exponential because it's not the same both times. 36, and then I'll do one more. 108 minus 81 is 27. Okay, so we need to figure out what percentage of each term is the next. So do 192 divided by 256, and you get 0.75. So if I do 256 times 0.75, do I get 192? Yeah. If I do times 0.75, do I get 144? Yeah. Times 0.75, hopefully I get 108. Yeah, okay, so I get it. Now, I got to figure out what I started with, and to do that, I need to go one more step. So if, maybe I'll write an equation, 3/4 of something is 256. What did they multiply? Do 256 divided by 3/4, or multiply by 4/3, and get 341.3. Okay, so that's what I'm starting with. Let me try that again. 256 times 4/3. Okay, it's 341.3. So I'm going to say the growth factor, that's the B, is 3/4, right? Because it's 75.75 each time. And the initial amount is 341.3 repeating. 341.3 repeating. So the model should be 341.3 repeating times 3/4 to the x. Let's make a table. 341.3 times 3/4 to the x. When I go to my table, did I hit it? 1 is at 256, 2 is at 192, 3 is at 144, 4 is at 108. Yep, we got it. Good. All right, so that's your model. Decimals? Okay, fine. So the next one, +2, +2, +2, +2, and the run is +1. So the slope is 2, and the y-intercept, I'll say b is, I don't like using b here and there, so I'm just going to say the y-intercept is 0, 3. So y equals mx plus b, the slope is 2, and the y-intercept is 3. Okay? Now, this b doesn't really mean the same thing as this one, so just be aware of that. Oh, I guess no, it doesn't. One more. Well, I guess two more. Let's see. What's the pattern here? 625, 250. What fraction of 625 is 250? 250 divided by 625 is 0.4. So times 250, is that? Yeah. So each one of these is 0.4. So the growth factor is 0.4. Okay, you can see that it's not the same every time. Like I can look at that and be like, those aren't growing by the same amount. So I find the growth factor is 0.4, and now I know it's a times b to the x. The a is 625 negative times 0.4 to the x. Let's model it. Negative 625 times 0.4 to the x. Oh, I got to get rid of all this. And then I'll go to my table. 0.4. There we go. Second table. So negative 625, negative 250, negative 100, negative 4. I got it. Good. Exponential. All right, let's do one more. And this one is adding 4, adding 4, adding. This is linear because they're the same every time. So the slope is 4, and the y-intercept is negative 9. So 4x minus 9. And if you want to check that one too, just because it's good practice, 4x minus 9. Go to your table. How we do? 0, negative 9, 1, negative 5, 2, negative 1. We got it. Good job. All right, so get your math lib assignment done and smash that like and subscribe.